Omega-3s. So when you come across health foods which are made with nuts and seeds, you may often hear the packaging say loaded with the goodness of omega-3s. Or here's something that a lot of my clients have encountered. I will recommend that they get a fish or algae oil supplement for omega-3s, and instead the person at the health store will say you don't need that, here's flaxseed oil, that's omega-3 as well. In fact, it's plant based and it's cheaper. Mind you, there are enough articles also on the web that make a similar claim about omega-3s that come from flax seeds or chia seeds. Each one of these is not just misleading but also biochemically incorrect. So today we will get into the mystery of omega-3s, and hold on tight because there is a lot of chemistry to get into. First things first, our bodies cannot make omega-3 fats on their own, and hence they are considered essential fats and must be a part of our diet. Now there are three main types of omega-3 fats that we get from our foods. The first is called ALA, and this is essentially what you get from all your plant-based sources. So this could be from your nuts, from your chia seeds, your flax seeds, etc. And the other two omega-3 classes are DHA and EPA, the sources for which will typically be things like salmon or mackerel or deep sea fish or algae. You can also get them from meats and eggs, but at very low concentrations. So for now we will stick to the acronyms of these omega-3s, and here is how I will suggest remembering them. ALA comes from plants and DHA and EPA comes from deep sea sources. Now here is where the differences begin. When it comes to DHA and EPA, the body directly uses it for functions in tissues and especially in cell membranes. As a result, they have important roles to play when it comes to the brain, when it comes to vision, when it comes to cognition, control of inflammation, etc. The problem with ALAs is that there is no direct function in the same way. So why is it that all three of these are clubbed under the same umbrella and just considered to be omega-3s and equal? Part of that has to do with their chemical structure. They all essentially fall under the umbrella of polyunsaturated omega-3 fats. So let's start with DHA. This is what a molecule of DHA can be represented as, and this is called a ball and stick model. And in here, each of the black balls is essentially a carbon atom, each of the white ones is a hydrogen, and each of the red ones is an oxygen. Now the first thing we want to check in this molecule is, are there any carbon to carbon double bonds? And we find that there are 6. So clearly this is an unsaturated fat, and it doesn't have just one double bond, it has 6 of them. So it's a polyunsaturated fat. The next thing we will do is start from one end of this chain, which is known as the omega end, and I have circled this in blue, and then start moving from carbon atom to carbon atom until we find the first one that has a double bond on it. And soon enough we find that it's the third atom, and that's what makes this an omega-3 fat. So in all, it's a polyunsaturated omega-3 fat. It's finally time to come to the actual names. DHA stands for Docosa Hexaenoic acid. Docosa is essentially 22 because there are 22 carbons in this molecule. Hexa is 6, that's because there are 6 double bonds in here. Let's come to EPA. This is what the molecule looks like. Now again, we are going to find 5 double bonds, so it is a polyunsaturated fat. And if we start from the omega end and start counting, we will find that the first double bond happens at the third carbon. So this is also an omega-3 polyunsaturated fat. EPA stands for Eicosa Pentaenoic acid. Eicosa is 20, there are 20 carbons, penta is 5, there are 5 double bonds. Right? And finally let's come to ALA, which is Alpha-Linolenic acid. Now again, if you look in here, you are going to find 3 double bonds, so it's polyunsaturated, and the first double bond is present on the third carbon from the omega end. This is also omega-3. And this is where the problem lies. All 3 of these are omega-3 polyunsaturated fats, but that is about the only thing that is common across all of them. How can one be the same as the other 2? This would be like claiming that petrol, diesel and kerosene are all one and the same just because they are all fuels. Of course, they will all combust, but they have varying degrees and varying properties of combustion, and hence they have different uses. It's the same in the body. The body has clear immediate functional use for EPA and DHA, but not exactly for ALA. So if you were to give it an omega-3 food containing EPA and DHA, it's good. But if you were to give it plant-based omega-3s, which is ALA, the only option that it has is to convert it into EPA or to DHA. And for this it is going to need a few extra steps and enzymes. For example, If you want to convert ALA to DHA, you need to add 4 carbon atoms and you need to increase the number of double bonds in the molecule by 3. You basically have to go from 3 to 6. But that's where the problem lies. The efficiency of this conversion is extremely low. It can be anywhere from under 1% all the way up to 8%. And not just that, the same enzymes that control this conversion are also used for omega-6 fat processing. So there is a competition between the two if both fats are present in your diet. So let's put all of this chemistry into perspective. Let's assume you need about 1000 milligrams or 1 gram of omega-3 on a daily basis to be healthy. Now you can get this from about 1.5 grams or 1500 milligrams of fish oil or algae oil, or you will need to consume about 20 to 50 grams of ALA to get anywhere close to 1 gram of omega-3. What this would also mean is about 15 calories of the fish or algae oil or up to 200 calories of the plant-based omega-3. You do the math. So why is it that this is never clarified by health food companies or nutritionists? Well, it could mean that either A, they don't understand the biochemistry, or B, they do and they're hoping that you don't. As with anything to do with health and nutrition, the choice of truly understanding the fundamentals lies with you. If you've enjoyed the way Truleen presents the science behind fat loss, health and fitness, please like, subscribe and do share these videos.